Welcome to a new In the Mail, the series that will touch both your passion for electronics and your bank account at the same time. Let's get started. First up, I have this thickness gauge meter. I already took this out of its packaging because I was curious to test it on a few surfaces. This gadget actually has a user manual that you can understand. There is no Chinglish like we are used to seeing. So the main purpose for this device is to measure the thickness of non-magnetic coatings such as paint on metal surfaces. It can measure between 0 and 1.8 millimeters with a resolution of 0.01 millimeters, which is pretty nice. It also has some calibration procedures built in, and they're described in the user manual. But to do that, I need some thickness standards with some predefined coatings. Those were not supplied in the package. However, one might use the tool without calibration for relative measurements by checking different spots on a sheet of painted metal to check if the paint has an even coating across the entire surface, or even for absolute measurements, but you are relying on the calibration that is supplied from the factory. And I'm not sure if they calibrate the device before shipping. Or another application is to check the different parts of a car to see if they have been repainted to a different standard. I'm not really sure how this thing works. Maybe ultrasonically, because there is a very small hole on the front of the device. Maybe it shoots a beam at the surface. The beam goes through the paint and it reflects back, and depending on the reflection you calculate the thickness. I don't know, but let's do a very quick teardown to see what they use inside. So it looks quite nice inside. We have a nice looking FR4 PCB with very decent soldering. Looks like we have an STM8 microcontroller in here. A couple of passives here. This might be a power supply, it might be a step-up power supply. We've got two wires going to the sensor, which is marked L1. So it could be some kind of inductive measurement method. Let's check the numbers of this chip right here. So this is a 74HC4060. So this must be a pretty recent design if they're using an STM8 microcontroller. And you can see how they can get the cost down, because everything is on a single board, just a couple of chips, some passives, and an LCD display. So I need to investigate this subject a little further to find out how they're doing the inductive sensing on the coatiness, on the thickness of the paint coating. But quite interesting, we have a date code on the PCB. It's 2017, 20th of April. So, like I mentioned, quite a recent design. As usual, you will find links in the description below for all the items shown in the video, so don't forget to check them out. Next up, I have some connectors and crimps. These ones are called butt splice connectors, and I find that name slightly amusing, I don't know why. There should be 100 pieces in here in 3 different sizes. Let me just open the bag so I can give you a closer look. So this is how one of these looks like. Like I said, there should be 100 pieces in here in 3 different sizes to cover wire thicknesses from 10 up to 22 AWG. You could use these to extend a cable length, or to connect an additional cable by splicing it somewhere in the middle of an existing line. You simply crimp these on the bare wire. I really needed something like this a few weeks ago. I didn't have these, so I had to improvise. I used some end crimps that are supposed to go on the end of a wire, and it did the job, but I wanted to have the right stuff for future work, so I ordered these. Next, I also got this variation of splice connectors. These ones have the Heatshrink on top. Let me show you in a moment. So these ones have a piece of Heatshrink over them and some hot glue inside. So after crimping, you heat these up with the hot air gun. The glue inside will melt, and with the help of the heat shrink tube, it will seal the splice, making it waterproof. It's a pretty nice idea, and you can find these in all sorts of sizes. I think they're color-coded by size. I only got this size, which is suitable for 18 to maybe 22 AWG. Pretty useful stuff to keep in your toolbox for wiring jobs, especially in automotive wiring jobs. I was also missing some spade connectors, and I found this kit which has 120 pieces. It has 3 different sized spade connectors. You get 2.8, 4.8 and 6.3 millimeter spade connectors in here. These are just the female connectors in this kit, and you also get the rubber insulator. If you also need the male connectors, I think you can find those separately, but those are usually found on relay terminals or soldered onto PCBs, so you are usually working on the other end on the wires that will need the female connectors. Next, I got this very small GPS module. Let me just get it out of the ESD protection bag. So this is the module. Look how tiny it is, and with this small ceramic antenna. The part number is ATGM336H, and it's supposed to be a Neo M8N replacement, and when I saw the title I immediately purchased one. The price is quite attractive at around $8 with free shipping, certainly cheaper than the M8N modules, but I later realized it's not quite a replacement, because with the GPS module that we have on this module, the 5N31 variant, and here is the datasheet of the module. Here we have the 5N3X, and if we look at this table, it can only cover GPS and BDS satellites. It does not connect to the GLONASS GPS system, while the M8 GPS chip from Neo can connect at the same time to multiple GPS systems. It can connect to GPS, Galileo, GLONASS or Beidou. So it looks like this module might be good for China, but not so good for Europe or the US. Because the Beidou satellite system, as far as I know, it only covers China and its surroundings, while GPS, Galileo or GLONASS have coverage over the US and Europe, so it makes sense to have a GPS module that will communicate with those systems. This Chinese module does have the advantage of being very small. In fact, let's check the size. It's about less than 14 millimeters wide, and less than 17 millimeters long. This is just a breakaway tab from the panelization. So yeah, pretty small. And if you're looking for something compact and don't care that much about connecting to different satellite systems, you might want to give this one a try. Or if you live in China, this really is a good alternative. I have also ordered a Neo M8 module, and when I receive it, I will compare these two side by side to see which one connects to more satellites from my location. Next up, also a replacement between quote marks. I was looking to purchase the HC05 Bluetooth module. That's a classic module, it has been around for years and everyone knows it, but I came across this device. The name of the module is SPP-C, so you'll find them under this name or simply HC05 replacement Bluetooth module. This new module, which is supposed to be compatible with the HC05, is cheaper. For example, I got this one for $1.55 with free shipping, which is not bad at all for a Bluetooth module. I remember 6 or 7 years ago I was paying $20 for Bluetooth modules with the same functionality as these. Whether or not this will work fully as a drop-in replacement for the HC05 modules will remain to be seen. This is still new and hasn't been tested fully. You will not find enough information on the internet. But I will be using this on a board I'm working on, and I have both an HC05 module and this one. I will be running the same firmware on the two, so it should be able to catch any problems caused by the replacement module. Until then, I'm pretty happy these cheap alternatives exist. By the way, if you're curious, this module uses the BK3231 system on chip, which is made by Beacon Corporation. You've guessed it, a Chinese manufacturer of semiconductor, and it's pretty much the future in terms of what we're expecting to see. Every chip and module that you know will soon have a pin-to-pin compatible device made in China that will cost less. That's what I'm expecting to see in the following 5 years. Next up, I got myself these sets of 3 amp ceramic fuses. These are 6 by 30 millimeters and these are 6 by 25 millimeters. They're both very cheap. These ones are marked Bossman but are probably just fakes. It's quite funny how I got these. It started with me blowing the fuse on my Agilent 34401 bench multimeter, which uses a 3 amp fast blow fuse for the amps range. While opening the fuse holder, I found a small 5 by 20 millimeters fuse inside, but the holder, this is the actual fuse holder, it looked like it could also hold 6 by 25 millimeters because it had these wider fins, but it turns out these fins are just for locking, are the locking mechanism, and the fuse actually needs to go deeper in that smaller diameter tube. So I went ahead and ordered the 6 by 25 and 6 by 30 fuses just to make sure I will have at least one that fits the system, but as it turns out none of these will fit. I need 5 by 20 millimeter fuses. Now I will not wait another month for the new fuses to be delivered from China. I will just order them from my local supplier, and these will go in my box of fuses. Hopefully I will use them one day. Also in the fuse department I have a set of 400 milliamps PTCs. These are resettable fuses rated for up to 72 volts DC and 400 milliamps. I honestly can't remember why I got this. It could be because I saw them on somebody else's channel in a mailbag. It could be because I was working on a project at that time. I just can't remember now. These are usually used on small circuits and modules that have low power usage. You want to protect the input on those circuits with a resettable fuse. If the user creates an overcurrent condition, the fuse will break and it will then reset after the fault has been removed. So it's a nice way of protecting circuits without having the user to replace a fuse. Next up I have this programmer called ST-Link V2. It's a clone, of course, not the genuine stuff. I believe you can get a genuine ST-Link V2 for about 25 euros or maybe even less if you order it from DigiKey. These can be used to program STM32 and the STM8 microcontrollers, and I've had one of these previously. It worked just fine up to a point. One day it stopped working. and it still gets power but doesn't get recognized by the ST-Link utility. So I just ordered another one. The cost is around $2.50 with free shipping, and I promised myself that if this one fails as well, I will get the real deal next time. It's just that I've been using it only occasionally, so I think it was worth to get the less expensive tool. But if you're interested of working with this in the long run, maybe you're better off getting the genuine stuff. So if you'd like to check this out, there will be a link in the description below. For my next item, I'm going to start with a question. Have you noticed that for the 1.3-inch OLED display, or maybe even for the 0.96-inch ones, it is cheaper to buy a ready-assembled PCB module with display than it is to buy just the bare display module? I need one of these 1.3-inch OLED displays for a project I'm working on, and if you try to buy this, just the bare display from eBay or AliExpress, you'll find it is slightly more expensive than a completely assembled module, which doesn't really make sense, but it is what it is. They're manufacturing these by the thousands, so it's cheaper to get them like this. I got one of these. I will just desolder the OLED screen and solder it on my board. I like these displays modules very much, better than the 0.96-inch version, but still at 1.3-inch I still think they're too small. If only we could find these in something like 2-inch size or 2.4-inch at an affordable price while keeping the aspect ratio and the resolution. It would massively improve the visibility when using them in a front panel for some equipment. But if you look at the current offer for OLED panels, you'll find the 1.5-inch color module that has 128 by 128 resolution. I'm not sure, but I think it was used on the newest Hackaday badge at the Hackaday conference. But that's not really suitable with that square aspect ratio for a front panel of an instrument. Then there is the 1.5-inch monochrome 120 by 64, which is the same aspect ratio and resolution as this smaller one, but in a 1.5-inch size. This one seems to be the closest to what I'm searching, but then if you go up in size, you either get weird aspect ratios or you don't get them in white, and they start to be very expensive. So you start switching to TFT panels instead. Anyway, that was my short rant on OLED panels. Moving on, our last item in this video is a set of latching relays. While normal relays will keep the coil energized for as long as you apply power, latching relays just need power long enough for the coil to energize, and they are latched then. You can turn the power off and they will remain in that state indefinitely. You could definitely see the advantages of such a relay. One example might be to keep the contact state even if power is lost, or another example are low power applications where you don't want the relay consuming power. As far as I've seen, these relays come in two variations. One of them has only one set of coil pins and you just reverse the polarity to change the state of the relay, while the other variant has two sets of coil pins and you need to energize them alternatively to change the state of the contact. I have the second type here, and you can see on this side we have the coil contacts, and we have two sets of these contacts. These are pretty small relays. They're only rated for 2 amps at 30 volts DC or 1 amp at 125 volts AC, but you can obviously get some higher ratings if your application requires that. So if you haven't seen these before, I recommend you order a couple. They are fairly inexpensive and you can learn how they work and maybe use them in your next project involving relays. That was all for today. You can find the links in the description below for all the items shown in this video. Those are affiliate links, so if you make a purchase after clicking those links, I will be receiving a commission from the seller. It's the best way of supporting